Hi everyone, me again after him about today Kukola for this channel in graphic designer. So how you guys doing? So hope you are enjoying our videos. So um this is like the last video from this video series that we are doing on crude distillation unit process simulation with Aspen Plus. So in the previous video, we talked about the atmospheric distillation unit here. So for the atmospheric distillation unit, you have the heavy naphtha, the kerosene stream, and the diesel and the AGO. Then for this, on this video, what we're going to do is the vacuum distillation unit. This that's the unit that we're going to model now. So actually, the main difference of what we have done in the atmospheric defense because atmospheric distillation unit is the parent network is going to be lower now, and there will be some configuration because most of the vacuum distillation unit is not as large as the atmospheric distillation unit. It's just to separate some of the light components in this residue. You understand when you take it to vacuum, I think there will be higher degree of more separation. You understand because so that's what I'm going to do. We are going to use the same model like we did for the atmospheric distillation unit to model the same Aspen Plus model. I mean the petroleum fact, but the configuration is going to be different. You understand? So and the structure of the model is quite different. It's not good like it's not going to continue strip. It's not going to contain three parts. It's only four parts. So like we have been doing in the previous video, we are still going to follow this textbook, this tutorial from Aspen Plus. You understand to use their process condition to check maybe it will work for our Nigerian coolant. So and we have been getting our results so far for the flash column and the atmospheric distillation column. So I'm going to start now. So to pick the icon for the petroleum fact, you have to use a vacuum icon. So I'm going to pick this one. It's more like you can see there are different kinds of icon. There you have icon for pre-flash. We can even change this onto pre-flash icon. I'm going to do that now. I want to check the one that is good because all these compound icon is not supposed to be there. So I'll check the one that is good. I think this one is too good because it's only vapor and liquid. So I'm going to change it to uh touch like pre flash 1F. Let's check if I can exchange the icon. It's so hard to get there because there's a lot of icons there. So we are following this until we reach 1, 2, 3. I think I skip the video to I think this is pre-flash. So this pre-flash one. So we can reshape our whole graphic. Let's make it new. We can even do it like this, align. So if you align it, this one can be turn it. So this is the light master. So this is of aspect. The okay. Okay. So this is it. So the code. That's beautiful shit, right? This is the thing. So we have this. I think this now better now. So maybe when I'm done, I'm going to log the flow sheet because Aspen Plus sometimes just change the flow sheet. So I'm going to pick the right icon now, so we don't have to be doing that thing again in this one. So click it around there. So that's the icon over here. I want to shift it to rename the column vacuum. So column is vacuum. So put it, let's put it there. So this is vacuum. So I have to connect this one to the vacuum. Then I want to drag it down. Then put it in the right place. So that's it. So the next thing is to connect the remaining stream. So we have the residue, the main residue here. So for vacuum, let me check. We cannot, I don't think we just have off gases and the side draws. So we just do that one. So just put the off gas. So the side draw, you have to be very clear that some water decant. Well, we are not doing water decant modeling for this one because it's not that important for vacuum. So okay, so side product. Just make sure that you pick the side product so that you don't miss it. Okay, that's that product. So you can draw the second one down. The second one will be the okay. So this one will be the alive. Okay, align it again. Align it again. So rename the stream of gas. Okay, let's say of gas already is vacuum of gas. So for this one is the vacuum of gas. So this one will be light vacuum gas oil. Light vacuum gas oil. You drag it down. So this one will be the heavy vacuum gas oil. So residue is the residue. It can be processed further, but not in the distillation unit. So we have the residue. So I think we have done. We can now go to. So we made the same. So let me. We have to put the stripping stream. So so let's say this thing. So this is the vacuum stream. So let's do the from the test from the tutorial. I think the steam is 450,000 pounds per hour. So we do that 450, then we check for water mass per pound per hour 20,000. Okay, that's that. So you go back to main cruise. I think all the inlet stream has been defined, so we can now go to the main stream. For the configuration, you check for number of stages. So for the number of stages, 6 equilibrium stage. So we have space. So the condenser, like I said before, there is no condenser. The pumper is adjusted as it is a service. There is no top condenser. Frequency is the bottom, no condenser. So we are going to make the pumper to be the first, to be to the top. We are going to make it to the top pumper so that it's going to be the liquid fit to the top page. You understand? So like recycle something. It's like when you are modeling full reflux. Yeah. So we're having this on versus the feeding. from it's from the bottom, it's also from stage 6. It's from stage 6. This one is also from stage 6. But if it is from the furnace fire, it's going to be on stage. Um, so um, so I think this one is done. What just going to be done vapor liquid. So the next thing is for the side draw. We have to specify the stage of the side draw. So for the side draw, we have something around there. Stage 2 for the light vacuum. The second is stage 4, and this one is 8,000 dBA. That's the flow estimate. But the first one is to be flow estimate. So I'll say 2 here. So, but we have to make it totally. That's what they are trying to say. Um, like all the liquid is going to be original. Like the light at total draw. So you have to make it totally. All the liquid that for that state is going to be taken out. Yes, I say although the first estimate is going to be 8,000 power per day, if during the calculation it is going to be calculated value, the flow, the stage flow rate is going to be calculated value. So during the stage calculation and the not 8,000, we're going to use that new calculation for the value of the flow for the light vacuum gas drawing gas oil draw it. So I'm just going to put in BBL, pick BBL for 8,000. I think this should be all these units that we're adjusting um should be automatic, but maybe I made mistake in the choosing the unit set when I'm starting the video, so that's why giving me difficulty. So so we do for the other side draw, which is the epi gas oil, vacuum gas oil, which is for page 4, 17,000 dBA per day. So this one is going to be 4. It's going to be liquid. That one is not total liquid, because based on what they said there. So you just withdrawn this way. So program made mistake. So I'm going to change this one to PDL per. Oh, BPA per day. Per hour, you want to trade the process per day. So we have this one is going to be 17, 1, 2, 3, 17,000. So it's done here now. So you go to prayer network. So the prayer is going to be let me give the prayer here. So the prayer is, I think the prayer should be 60 echo. So you pick echo for the top, then 70. That's normal people prayer. I use that for echo at the bottom too. So we do the furnace. So the furnace, like what they said there, the furnace is 0.6%, so 20% to fraction over class fraction over class. So okay, standard for 0.006 percentage. Then the prayer, we're going to do the prayer. The prayer is for the furnace 2.03 psi. Yes, I say done. So the next thing is the pumper, and we have to set, like we have already told you, you must put the pumper and we specify the condenser to be non-heat 4-stage pumper hand. So that's the pumper hand that we're going to use now. So it's going to be drawn it's already from stage 1 to from stage 2 to stage 1. Yeah, like a recycle. So 2 here. So 1. So we can specify the flow and the DTL. So the flow is 20,000 power per day minus 28 as estimate. We are going to use it to do something later. I think that's what they are trying to do. So you are going to put dBA per day again. Oh, I forgot to value again. 20,000 dBA per day. So second spec is the GT. So the GT is and minus 28. Minus 28, like I said in the previous news, cooling basis. You understand? So we do for the second pump around too. So the second pump around is there. So this one is going to provide the liquid flow rate for the downstage. We are taking the first, like they said, um, the second component provide the necessary reflux, liquid flow for the lower section of the tower because we are taking all the liquid out from stage 2. So it's going to be sent to stage 3 from stage 4. You understand? 4 to 3. So we have 4, 3. So you pick flow as the first in standard volume cubit. So this year per day. So what is the flow is 49,000. So it's going to be enough. So you pick the second spec, which is the DT again. So the second spec is minus 80 MBBTU per hour minus 80 minus 80. So this one too is done. So the next thing is now to do the design spec. Like I said, like we have to design something. So I'm going to do for vacuum here. We have to check some specification in our column. So we are building a column. We are getting a column that work with specification. So the specification that we are using is consistency or the first compound like before is estimated there. So it's adjusted so that the top of column temperature, we want the temperature at the top of column to be around 15. It's the same thing as just as using the condenser. I don't know why they want to use condenser. But because of vacuum, the process is quite different. You understand? Like so, um, so we have stage temperature. So you say 150 Fahrenheit. So you say one stage one, first stage, top of the one, 150. So you vary the pump around activity. So which pump around? Pump around one. Perfect. First pump around. So that's everything. So what this let's check what this should do. So you can check here. So I run the simulation and check. Okay, it work. Result available. I can't believe it. Let me check what happened in the control panel. Let's check what happened in the control panel first. So this is what happened. Warning issues. No errors and warnings. There's no error and warning. So everything was fine for the whole process. So the only thing is just we didn't do for the vacuum free water, like you said. Free water calculation is not there. So that's the only working. So we can check what happened in this, like we did for the other column too. So this is the provide. So we have the prayer note, and we can do some plot to value relative volatility of components in the page, composition of components in the page. So, all these components have different kind of liquid components in the page. Okay, let's see. So this is composition. So you know where to take like when you want to very large component. Even the key is too much. I'm plotting a lot of like you plot like high boiling point component and low boiling point component. Like our key component. Like if you want to do much component, you just pick two key components. So I'm going to use another plot. I want to check another plot like high boiling point component and low boiling component. So you can check the high from this. So this is high low boiling point component and this is the high boiling point component. So you plot for vapor. Let's plot for vapor first, then we make the plot. Can we even select the plot again? This is not the right component I want to collect. And pick from the middle and pick on components in the middle. So we can see this. So this is it. Okay, then. So this is the component. So this is the component. So this is the high boiling point component. So this is the low boiling point component. So you plot for vapor. Let's plot for vapor first, then we make the plot. Can we even select the plot again? This is not the right component I want to collect. And pick from the middle and pick on components in the middle. So we can see this. So this is it. Okay, guys. this is a this is the icon is one point company. Maybe it's not much in the I'm not even saying the blue one. The blue one is always zero. Maybe they are not much in the crude oil asset. So we can even check from the stream that which component is much in the crude oil asset. So let me get where is the crude oil mix skills. So you get the mix crude results. You can check the results for the mix crude. Uh, Polymer. Okay. Okay, let's do like general more flow. Let's do the more fraction. I'm the one that is very high, like 0.01 something. It is very difficult to get. Let's abandon it. So I think the next thing is to check the results of the column. So this is the pressure, top pressure, the bottom pressure, the temperature. You can see at specified 150 from here. So this is the furnace, the pop to liquid to temperature based on the temperature of the furnace. So the mass balance of the stream. So these are the stream giving the value. Okay, so you have a light vacuum gas oil, so we are getting, you can change this on to power per day. So this is power per day of like every vacuum gas oil and light vacuum gas oil that we are getting. So you can send your results to Excel, like all stream you can get for all stream here, the data for this for the simulation, like streams here. This for all the stream, send everything to Excel file. You understand? So you can continue to model or you can adjust things, do some optimization. So you can even export the variable link to the table. So once you click, once you adjust things, it's going to change it in the value of the in the Excel file. So if you have an existing worksheet, workbook of Excel, so you can change the format that you want. So that is right. So you just export it, then you give it a name for the Excel file that you want to do. So I'm going to do it here. So VDU, crude distillation unit. So let me just write it very well. Crude distillation unit. So it's going to work. I need to do this thing now. So that's all. So it's going to open the file in Excel now. So I'm going to open the file in Excel. So this is data for the simulation in Excel. So, but everything is linked. You can see all these values is linked path. So how to let's try and adjust, like recalculate the model again. I want to change something on the spreadsheet. So let's change the specification here. So one specification, like you can even see something before we change the specification. The stream results, that is the light vacuum gas oil, is not in the same, is not having the same volumetric flow that we specify for it. You know, specify 8,000, but it's still close to 8,000. So we're having 6,971.9 barrel per day. So that means, like I said, if it's not up to that, it's going to show you the calculated value. So so I want to change something so that it will reflect on the. So I'll change this onto. I'll change the specification of this temperature to from 120, and we run the simulation. So result is now available. Let me check the stream data again. You can see this flow will now be different. Let's check this is different. You can see 6920 barrel per day. So change it back to default unit. Because this forgotten the default. So this is the default unit. So that's why we're having 0.38857. So that's all on this video. I hope you enjoyed this video. Please don't do this channel for me to be giving you more videos on Aspen Plus, Aspen IC. Thank you.